Welcome back to the deep dive. If you've ever walked through, say, a modern automated warehouse or a big manufacturing floor where you see high-speed robotics working,
Mm,
you've been surrounded by these structures that look sort of temporary but are also incredibly rigid.
that's right.
Today, we are pulling back the curtain on the quiet backbone of that whole environment, T-slotted extrusion framing.
Yeah, and our mission in this deep dive is to really unpack this modular aluminum system. It's the unsung hero that forms the structural integrity for, well, for everything from machine enclosures to custom assembly lines.
It looks a bit like high-end scaffolding.
It does on the surface,
Yeah.
but it's fundamentally a precision-engineered safety and structure solution.
And it's a system that's really built for speed and adaptability, which is why it's so critical for, anyone in this space. For decades, if you needed a custom machine guard, you had to call a fabricator.
Oh,
You'd
absolutely.
have to cut steel, weld it, grind it, paint it, a multi-week process.
And a costly one, a very costly one. This T-slot system, it just flips that whole workflow. It's a high-strength, customizable solution where all that complex machining is replaced by this fast, flexible, almost plug-and-play construction.
So you can get the parts in bulk or kits.
Bulk, pre-engineered kits, or even fully assembled, and you can change the design on a dime.
That speed, that flexibility, that's the core appeal. But as soon as you start talking about manufacturing floors, you're not just talking about convenience, you're talking about mandated safety.
Right.
So let's jump into that core function. What is the main... so much.
The why is absolutely paramount. It is designed first and foremost to improve operator safety
Okay.
and to ensure regulatory compliance. I mean, we're talking OSHA standards, international machine safety standards. What's so fascinating here is that while we talk about its modularity, its function is intensely targeted.
Targeted in what sense?
They're tailored solutions. These aren't just generic barriers you buy off the shelf and, hope they fit.
Right.
They were engineered, sometimes down to the millimeter, to fit specific equipment, specific processes, specific facility layouts. The design have to be intentional to reduce operator exposure to, say, moving parts, hot surfaces, pinch points.
So the frame becomes a custom fit wall between the worker and the hazard.
Exactly.
That level of customization sounds fantastic. But, I mean, if it's just aluminum bolted together, how can it really compete with, the sheer strength of a traditionally welded steel enclosure? A high-speed machine can generate serious forces.
That's a crucial engineering point. The strength isn't just in the material itself, which is high-strength structural aluminum. It's in the geometry of the T-slot and how it's all connected.
Okay.
The profiles are designed to distribute load really efficiently, and the special connectors lock everything together with extreme clamping force. So while a welded frame is permanently rigid, this system provides a kind of reconfigurable rigidity.
Reconfigurable rigidity. I like that. So it's strong enough for the job, but you can still take it apart later.
Precisely. And in some cases, it's even preferable because of its vibration dampening qualities.
That's a key distinction. And you mentioned compliance. How does this system go beyond just being a physical fence to actually becoming part of the safety ecosystem?
It does that through integration. And that integration is built right into the profile geometry. Those slots let you mount almost any accessory seamlessly.
Okay, so you're not just drilling holes wherever you feel like it.
No, no. And this is critical because the frame is designed to hold essential safety components. We're talking panels, doors, sensors, and very importantly, safety interlocks.
Let's focus on those interlocks for a second. For someone listening, what does a safety interlock actually do in one of these enclosures?
An interlock is basically the digital safety layer. So you have a hinged or a sliding door on the enclosure, right? The interlock sensor is mounted right there on the frame. Its job is to make sure the machine inside cannot start or shuts down immediately if that door is opened.
It's a kill switch.
It's an intelligent kill switch. It prevents operator error. It prevents accidental exposure to moving parts during operation. It satisfies the absolute strictest compliance mandates. The frame is the housing that physically supports that digital safety function.
So the aluminum profile ensures compliance by being the rigid structure that literally holds the keys, the interlocks, to stopping the machine.
Exactly. It's the physical barrier and the foundation for the electronic failsafe. A holistic approach.
Fantastic. So the why is safety and compliance. Let's get into the how. What are the components that let us build these things? If you're looking at a supplier catalog, what are the three essential building blocks you're going to see?
Okay, so the first And the most obvious is the foundation, the T-slotted extrusion profiles
The
themselves.
beams, the
The
skeleton.
whole skeleton, yeah. They're high-strength aluminum profiles extruded with that very distinctive T-shaped slot running down their length.
And I think the key takeaway here is the minimal machining you mentioned earlier. How big a deal is that in a project timeline?
It's, it's, it's transformative for deployment speed and for labor cost. Think about it. Traditional steel fab requires a welding shop, certified welders, grinding the joints, then painting or powder coating it.
A lot of steps, a lot of specialized labor.
Highly skilled, time-consuming labor. With T-slot, you can often just cut the profiles to length on-site with a good miter saw. A fraction of the complexity. You size it, you assemble it with simple hand tools, and you're done.
So it completely shifts the skill set needed from a certified welder to really an assembler.
That's it, which is a major cost saving.
Okay, so component number 2. This takes us to visibility and protection. The barrier itself.
Right, these are the protective guarding panels. When you build a guard, you can't just build a solid box. Operators need high visibility to monitor the process, check for issues.
But that barrier still has to be strong enough to contain a catastrophic failure, right? What materials are we talking about here?
Usually you're looking at shatter-resistant clear materials, and most often that means polycarbonate.
Not just plexiglass.
No, and this is crucial. Standard plexiglass or acrylic might crack or even shatter under a high impact. Polycarbonate, though, has significantly higher impact strength. So if a tool breaks or a part gets ejected at high velocity,
Which happens.
it's a serious risk in automation, yeah. The polycarbonate panel provides that impact protection. It contains the potential shrapnel while still giving you clear visibility. It's the perfect balance.
So the panel isn't just a window, it's a containment device.
Yeah.
Got it. Now the third element, this is where the magic of modularity really happens, the connectors and fasteners.
Indeed. The connectors are the engineering secret sauce. And it's not just one type of bolt. There's a whole family of specialized fasteners. You have things like end fasteners and anchor fasteners for your really high-load applications.
So if I need a super strong, permanent feeling corner, I use one of those.
Precisely. They slide into the T-slot and expand to lock rigidly. But then you also have lighter, more elegant solutions like the modular T-slot connector.
And what's the use case for that?
That's often designed to secure, say, 3 profiles meeting at a 90-degree corner. The beauty there is that these connectors are usually drop-in or slide-in.
Meaning you don't have to take the whole thing apart to add something.
You got it. You don't have to disassemble the entire frame just to add a vertical support later on. It dictates the geometry and locks it all together with minimal effort.
That ability to modify without a complete tear down, that has to be the key to the whole system's flexibility.
It is.
Okay, so we have the skeleton, the skin, and the joints. But any serious structure needs stability, especially with all the vibration on a factory floor.
Absolutely. Once you have the frame built, the next conversation is always about structural stability and the finishing details that take a structure from just being built to being professionally compliant and safe.
Because a guard that can be nudged or toppled is not really a guard.
It's a safety risk waiting to happen. Yeah.
So how do we anchor these things? What stops the frame from wandering around the shop floor?
Here we get into essential accessories, starting with rigid mounting brackets. Think of these as the floor-to-frame components.
Feet.
The feet, exactly. They're designed to transfer the frame's weight and any lateral forces directly to the factory floor. They secure the entire structure, usually with heavy-duty anchors, and just eliminate any shifting or swaying. Stability is non-negotiable.
I can imagine with big stamping machines or CNCs, vibration is a constant enemy. So these brackets are what keep the joints from working themselves loose.
That's a great point. They mitigate the cumulative effects of all that vibrational stress on the connections. Stability is structural security.
Now, what about the details that seem less structural? I mean, hinges and handles are obviously functional, but let's talk about the purely aesthetic add-ons, or what seem purely aesthetic. I'm thinking about those little plastic caps you see on the ends.
The snap-in end caps. Those are fascinating because they perfectly illustrate the dual role of the system, both safety and aesthetics. On one hand, yes, they provide a clean, professional finish. They hide the rough-cut ends of the extrusion. They prevent dust from getting in there. But they serve a critical safety function.
Which is?
They protect the operator from the exposed metal ends. Even aluminum, when you cut it, can leave a pretty sharp edge. Or it leaves an open channel that can snag clothing, or worse, injure an operator who's reaching around the frame.
Ah, I see.
The snap-in cap just eliminates those sharp edges instantly. It creates a clean, smooth profile that actually satisfies compliance requirements about minimizing laceration hazards.
It's such a small detail, but it really drives home how comprehensive the design philosophy is.
It is. It considers the big picture structure, the rigidity, the visibility, all the way down to the final safety detail of preventing a snagged uniform. It's a holistic, top-to-bottom approach.
Okay, for you listening, let's synthesize this. We started by contrasting T-slot with traditional fabrication. Let's review the three major benefits that make this system so dominant today.
The first has to be speed and cost reduction. And that comes directly from needing minimal machining. You cut profiles quickly, you assemble them with standard tools, you just slash the specialized labor and deployment time.
Second is flexibility and reusability. The frame can be easily modified, expanded, or even completely disassembled and reused for something else. In a dynamic environment that's constantly being optimized, that is invaluable.
And finally, number three is targeted and certified safety. The tailored fit, the easy integration of things like safety interlocks, the use of high-impact panels, it all ensures the structure meets the strictest compliance needs.
When we connect that standardization to the bigger picture, it's kind of an industrial paradox. What's so fascinating is how the simplicity of a universal geometry, that single T-slot shape, allows for such infinite complexity in custom applications.
It's the brilliance of highly optimized standardization. You start with this one basic geometric profile, and because every accessory, every connector, every panel is designed to fit that one groove, you can build, well, anything.
From a simple cart to a massive enclosure.
A simple guard to a complex, climate-controlled, multifaceted machine enclosure. It allows for these high-strength structures, tailored for maximum safety, all built from the same set of off-the-shelf parts. The standardization guarantees both resilience and adaptability.
So what does this all mean for us? T-slotted extrusion framing is just a compelling example of how a simple, standardized design, the T-slot, can enable rapid, resilient customization in a hugely demanding, safety-focused field.
It really is.
It's the ultimate lesson in how standardized components can unlock limitless engineered solutions.
And this raises an important question for you to mull over. Given the proven effectiveness of this T-slot framing for building flexible, strong, and adaptable structures in factories with minimal machining, where else could this philosophy be applied? Could this modular, bolt-together method revolutionize how we approach, say, temporary housing or emergency disaster relief infrastructure? What about complex structures for space habitats where speed and minimal on-site fabrication are absolute necessities?
Something to ponder until our next deep dive. Thank you for joining us in unpacking the backbone of industrial safety.
Always a pleasure.